actually start doing some problems. So we got Maggie and Elizabeth, and they both have a bag of M&Ms, and they've opened them and counted, and they know how many of each they've got, and the probabilities are listed there. So let's make sure you understand the table. Look at Maggie's bag. It says green and then 0.3. That means that 30% of Maggie's M&Ms are green. 3/10 of her M&Ms are green. 20% are yellow, and so on down the line. Now notice, all of Maggie's numbers add up to 1. Does that make sense to you? Because don't all the percentages have to add up to 100? Yeah. And the same thing with Elizabeth, but her numbers are different. She has a different bag of M&Ms. Okay. We're looking at A. If a candy is chosen from Elizabeth's bag, what is the probability that it will be green? 0.2 or 20%. And I don't care which way you answer. You can say 0.2 or you can say 20%. If a candy is chosen from Maggie's bag, what is the probability that it will not be yellow? 80%. Because what does not yellow mean? Anything else? And all the rest of them make 80% or 0.8? That makes sense to everybody? If a candy is chosen from each bag, what is the probability that they will both be red? Well, what's Maggie's red probability? 20, 0.2, 20. And what's the probability of Elizabeth's? 0.3. Now, here is where I really need you to pay attention. Remember those problems where I said, I have 10 shirts and 5 jumpers, how many outfits can I make? We said it would be 10 times 5 because I was picking a jumper and a shirt, and whenever I do this and this, it's a multiply. I am picking red and red. So I'm not going to add those two numbers. What am I going to do with them? Multiply them. So the answer, be real careful with your multiplication, might want to use your calculator, it's actually 0.06 because of the decimal points.
What's you're doing it like 80%?
You need to do it decimally. When you do math operations with percentages, you always change them to decimals, Caroline. We don't want to do any math with a percentage. It gets too confusing. So 0.2 times 0.3 is 0.06. Everybody got it? All right. If a candy is chosen from each bag, what is the probability that neither will be brown? All right, so look at Maggie. What's the probability of no brown out of Maggie? 0.8. And so times no brown out of Elizabeth. 0.9. So I multiply those and my answer is 0.72. Does everybody understand where the 0.8 came from? And the 0.9 and the 72? In Elizabeth's bag, the probability of getting a brown is 0.1. That means the probability of not getting a brown is 0.9. Everything else. We don't want brown. Read the question. We do not want brown. If a candy is chosen from each bag, what is the probability that the first one will be green and the second one will be blue? All right, so the first one is green, so that would be 0.3. I'm on problem E. So I'm gonna go to Maggie, and I wanna get a green one from Maggie. And I wanna get a blue one from Elizabeth. Yep. So 0.06.
How do you know it's starting, which one is which? How do you know that you're taking one from both bags?
Well, if a candy is chosen from each bag, so I'm taking one candy from each bag, and the first bag, I want a green one, and the second bag, I want a blue one.
But could it be switched?
Not in this problem because it's ordered. Look at the next problem. If a candy is chosen from each bag, what is the probability that one will be blue and one will be green?
But, I mean, like, how do you know that Maggie's bag is first? Is it
Because it's
listed
written
listed
first
on
in the
there?
problem.
Okay.
Yeah, it's written first in the problem. It's considered the first bag.
Is there no 0.4?
I mean, there could be, but there isn't.
Well, of 9, of chapter 9. I was asking you.
Oh, yes, there's a 4 and a 5, and we're gonna do those two.
Okay, I was just wondering.
Yeah. They're a separate unit, though they're different.
Okay.
You know how we split some other chapters? This one's kind of split too. All right, let's look at F. Now, what's different about F, guys? I still want a blue and a green, but now they don't give me any order. So now I could do blue and green, or I could do green and blue. Either way. So blue and then green would be 0.02. Blue out of the first bag is 0.1. Green out of the second bag is 0.2. Now what about green and blue? Well, green and blue would be 0.3 out of the first bag and 0.2 out of the second bag, which is 0.06. Now what do I do with those two numbers? Keep in mind, it's blue and green, or it's green and blue. What do I do when I use that word or? I add them. I want the total. What's the total probability? It would be 0.08. The total probability of getting one blue and one green. I can do that two different ways. I can do blue and green. I can do green and blue. They both count. They're both fine. I total them up, add them up. Now what about the last one? G. If a candy is chosen from each bag, what is the probability that neither will be red? All right, Maggie, not red. 0.8. And Elizabeth, not red. 0.7. So 0.56 is the answer to the question.
About 5 more minutes. That clock's right.
The clock's wrong?
No, I think this clock is right.
Right?
Yeah.
Don't give me like.
You get like 20 minutes slow.
I'm gonna doze off.
You guys, this is your favorite class of the day. You
Will,
can't
you
fool
pray?
me. Here we go. Next problem, which I guess is number 2. I think I'll punch a hole through the number. It's number 2.
You
All
ready
right?
for the card
Yeah,
problem?
Will, did you study your
Yeah,
cards?
hope to God we don't have to.
Card problem.
Ms. Ford, I don't even own cards.
Dana, can you
I can
confirm
bring you
that?
a deck.
You don't, I don't want you to go out and buy a deck of cards.
I'll play
But
it.
you can get on your computer, your iPad, or your phone, and you can look at how the cards are. It's very, very simple. All right, so here we go. First thing I want to point out is that anytime the problem says what's the probability? You're going to have a fraction. Remember, by definition, probability is what you want over the total, right? So it's always going to be set up as a fraction if it says what's the probability. Question number 1, they all say what's the probability except number 1. Number 1 just says how many hands are possible. That is not a fraction. How many cards are in the deck? 52. How many are we choosing? 5. So the answer to question A is simply 52C5. So that is how many hands are possible. So 52 NCR5, it's 2598960.
Aren't there 13 in each suit?
13 in each suit and 4 suits. So there's 52 altogether. Yep. Now, here's the good news, sort of. See how all the rest of the questions say what's the probability? This is the denominator for every single one of the problems coming up, because that is the total number of 5-card hands. So your denominator is going to be 52C5, or you can write out the number, okay, for every one. So let's see what, this is the answer to A. Now what does B say? B says, I want to get all diamonds. So my denominator is still this number, 52C5. All the cards, pick 5. What's my numerator if I only want diamonds? 13C5. Why 13? Because as Caroline just said, there's 13 diamonds. Right? Now when I type that into my calculator, and you can type it in all at once, I don't care if you type it in like this, or if you type in 13C5 divided by that number, whatever's easiest for you. This will be the denominator for every single one of these problems. This will be the denominator every time you pick 5 cards. So here we go. 13, 5, divided by 52, 5. Did you get an E number? Okay, now remember, you're not going to write that down. You're going to write the decimal, or its scientific notation, whatever's easiest for you. So decimally speaking, this is the number. Oh, wait, no, too many zeros. That's the number. Or you can write 4.95 times 10 to the negative 4. Whatever is easiest for you to write down. Would you agree that's a really small number? So are you going to sit down and make a bet with somebody that they can deal you an all diamond hand?
Yes.
No, you. If they're telling you they think they can get an all diamond hand, that's okay. But don't you say I'm going to get an all diamond hand, because you're going to lose every time, right? That probability is really small.
Can I interrupt you real quick?
Sure.
I have a question, Ms. Fuller.
Yeah, sorry.
As far as like rounding, are you doing that? Like if it was 4.9 plus 6 would be
4.96?
Yeah.
Yeah, I'm rounding like regular. I didn't pay that much attention.
No, I'm just thinking like.
Yeah, there's a 1 after that, so that's right. All right. What? How many face cards?
16.
I think there's only 12.
No, I know that was wrong. So it's Jack.
Jacks, and there's 4 jacks.
14.
There's
12 base cards.
4 jacks, 4 queens, and 4 kings.
Kings, yeah.
Oh, I just did 4 times where I messed it 4 times.
Okay, but so you got it?
Yeah.
So there's 12 face cards. So for C, it's just going to be 12C5 over 52C5? Because there are 12 face cards and we want all of them. Get all face cards. That's going to be an even smaller number.
Yeah.
So don't bet that you can do this, please. I got 3.05 times 10 to the negative fourth, or 0.000305. Now the next one will be better. What's the probability of being dealt an all red hand? What will all red look like? Denominator's the same. 26 C5. Boys and girls, this does not reduce, like some people say, oh, 26 over 52, 1/2. No, 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 no. No, no. Gotta type it in. Doesn't work that way. Did you get 0.0253? Which is still a very small percentage. It's about to have a 2.5% chance of getting all red. All right, do you have an idea for E? We want 3 jacks and 2 kings. Your denominator is the same, 52C5. What would 3 jacks and 2 kings look like? They're going to be multiplied. So you're going to have whatever you do with your jacks is going to be multiplied times whatever you do with your kings. Yep.
It was 15. Or we just, I couldn't. Is it 3 times 2?
Is it what?
3 times 2?
No, but I get your logic there. How many jacks are in the deck? How many jacks are in the deck? 4? 4 jacks? And we want 3 of them? So that'll be 4C3. You know how when you wanted diamonds, you said there's 13 diamonds and I'm going to pick 5? We'll do the same thing here. There's 4 jacks and you're going to pick 3. And how many kings are there? 4. And you're going to pick 2. So there's your 3 jacks and your 2 kings. That can all be typed in at one time or separately, whatever flips your switch. So 4 math NCR 3 times 4 math NCR 2 divided by 52 math NCR 5. Oh, tiny, tiny number. I got 9.23 times 10 to the negative 6th, which would be this right here. Very, very small numbers. Engage that brain and see if you can get F figured out.
How many math face cards?
Well, how many, remember we just had a problem, how many face cards were there? 4 jacks, 4 kings, 4 queens, so there's 12 face cards. 52 in the deck, so how many are not face cards? 40.
So would it be like the number of cards or just face cards? See that 40? Like 12 people?
No, no, no. You're picking cards that are not face cards. So here's your deck. You've put all the face cards over here, and they're out of this problem. You're not using those 12. You want these. There's 40 of them here, and you're picking 5 of them. So that's going to be 40C5, and then divided by 52C5, because we're picking 5 cards out of the whole deck for the total. It's a 5-card hand. Every one of these problems is a 5-card hand. And I want all 5 of them to be not face cards.
So would that first question be like the lineup for all of the C, like the number C?
What do you mean?
The first question, like how we figured out 5?
That's your denominator, yep, for every single one of these, because they're all 5-card hands. And this is how many 5-card hands there are. So that's the total, that's your denominator. Now, if we went to a 4-card hand, then your denominator would be 52C4.
How does G work then? There's only 4.
Yeah, I'm not ready yet. All right, so let's type that in. That should be a better probability. That should be a little higher. What?
Well, no, it's okay.
This one is about 25%. Would you agree? 25.32%? All right, so what's next? What is the probability of being dealt a 5-card hand and having all of the aces? Now, our denominator is going to be the same.
Can it be 48 C5?
Now, what would that be?
Oh, that would be non.
That would be no aces.
Yeah.
Yeah. If I want all, how many aces are there? 4, and I want them all. Wouldn't that be 4C4? But here's what makes this problem tricky. It's a 5-card hand. If 4 of them are aces, what is the other one going to be? Anything that's not an ace? And how many not ace cards are there? 48. So you're going to have 4 aces and, whoops, 1 other card that's not an ace. That's tricky. You got to think about what's going on. You need 5 cards. If I give you 4 aces, I have to give you another card, right? Because you won't have enough. And that other card is going to come from the 48 that aren't aces. You have 4 aces. You're choosing them all. There's 48 random other cards, and you need 1 of them. Okay, it's going to be really small. It's a really small number. Actually, it's not as small as one of the others. This is 1.847 times 10 to the negative 5th. Is that what you got?
Yeah.
And you always have to put the denominator in parentheses, right?
Not if this is all that's down there, but I'll tell you what, Mary Kate, you will never go wrong putting your denominator in parentheses, so if it's easier for you just to do it all the time, do it all the time. It is not gonna hurt anything. Oh my, what is the probability of being dealt a 5-card hand, so I know my denominator is 52C5, and having 2 10s, 2 jacks, and 1 queen? Ideas?
There's 4 types of 10s, there's 4 types of jacks, and then there's 4 types of queens.
Okay, so let's start there. There's 4 kinds of 10s, you said. And I want how many of them?
2.
So that would be 4C2. There are 4 10s to pick from, and you're going to pick 2 of them.
And then would it be the same for jacks?
And there's 4 jacks and you're picking 2 of them.
But then you have to do 4, 1.
And there's 4, what was the last thing? Queens, and you're picking 1 of them. So all of that is in your numerator.
So,
Just like she said, there's 4 10s, and you gotta pick 2 of them.
is it because they're all equal to 5?
Yep. So 2, 2, and 1, these are the cards you're picking. So you're picking 2 of these, 2 of these, and 1 of these. So that gives you your 5. All right, that's gonna be, I don't know what it is.
5.54.
Is it another scientific notation problem?
Yeah.
5.54 times 10 to the negative 5th.
Yeah.
All right, let's just take a second and see if you can do this last one. See how far you can get with it. I know you know the denominator because the denominator is the same for all these problems. William, you got a thought?
I have 2.
You have 2 thoughts?
Yeah.
All right, give us one.
One thought is, so there's 12 cards you don't want,
Mm-hmm.
so you could do 40 C5. That's my one idea. My other idea is 4, no, that's not right. I don't think it's right. 4C0 times 4C0 times 4C0. But I think that'll not get you an answer. Over 52.
Don't go 0.
You aren't done with this thought. This is a fine thought. What you're telling me is, I want no aces,
Queens.
I want no queens, and I want no 5s. Well, what do I want?
You want all the other ones.
So I want 5 of the other ones. These 2 are both exactly correct and they're equal because these are just 1s. This is a 1, 1, 1, so it's like it's not even there. This is the way I would have done the problem, but this is equally fine. They're exactly the same. Does everybody understand why she's saying 40? Because we're taking out the 12 that we don't want. She does not need to put all this in here, but you can. It won't change anything. I think I already did this. I thought that was a problem I already did, but maybe that was a different period. Let's see.
Oh, yeah, it's
We didn't get any scientific notation.
Yeah, was this the one that was like 25% or something?
Yeah.
0.2532.
I thought we'd already done it in another situation.
What is you doing back there?
So the answer is 0.2532.
Yeah. Hey, let's be done.
Will be done. Will be done.
Homework due
Good job.
Monday.
Vincent, you gotta stay for the prayer, please.
Nah.
But we're done.
Nah. I thought that was